Hello, beautiful people, and welcome. In this video, we are factoring quadratic expressions. Now, we are doing examples where your leading coefficient, your a value, is 1, and when your a value is not 1. As always, if I make a mistake, I'm human. Let me know where the mistake occurs so that way I may learn from it. Let's jump in with example number 1. Now, step number 1 always, let me just do a thinking bubble here real quick, is factoring out a GCF. So step number 1, locate a GCF. Now, GCF is something that you can divide out or something that you can pull out of every single term. For example, I see a 2, a 10, and a 72. And you want the largest number that can come out of every single term. So the largest thing that can come out of 2 is 2. The largest that can come out of 10 is still 2 because 2 is what we're limited to. And 72. So I'm going to pull out a 2 here. So I'm going to say 2 is not my GCF. I hesitated there for a second because I also noticed that I have a P, and a P in every single term. Now, your GCF does not have to be strictly a numeric. It doesn't have to be a number. It can also be a letter. So in this case, we also have P in every single term, so I can pull out P. Now, the reason we are not pulling out P cubed or P squared is because we are limited to the smallest quantity that is in each term. For example, the largest thing I can pull out of P is 1p. So therefore, I cannot pull 2p's out or 3p's out. So that means p is the largest quantity that I can pull out. Same thing with 2. 2 is the largest quantity that I can pull out because 2 is the smallest number. Now we have to write what is left over. So if I remove 2 and 1p, that means I have p squared left over. If I remove 2 and 1p, that means I have 5p left over. And if I remove 2 from 72, that means I have 36 left over, negative. And p is removed, so I no longer have p's. So what started out as a trinomial with the leading coefficient not 1, we now have inside our parentheses, inside our bubble, we now have a trinomial 1, 2, 3 with the leading coefficient of 1. So for a leading coefficient, the way to factor is called the guess and check method. So I'm going to put 2 bubbles. You're going to write whatever variable you have here. In this case, we have p. And then what goes next to p is what multiplies to your constant, which is negative 36, and adds up to your middle term, which is a positive 5. So I'm thinking 6 times 6 is 36. However, 6 has to be negative, one of them. And when I add them together, a positive 6 and a negative 6 gives you not 5. So we need a 5. So I'm also thinking maybe 9 and 4. 9 times 4 is 36. However, 9 minus 4 is 5, which we need. So let's do that. We're going to have a positive 9 and a negative 4. Now, the reason 4 is negative is because this middle term needs to add up to a positive 5. Therefore, the positive needs to be a larger number. I'm going to bring down your GCF. Don't forget your GCF. And we are done factoring this one. So I'm going to put it in a box. Let's go ahead and do example number 2. Example number 2, we start out, is there a GCF? I have an x, no x. I have a 10, 11, no number. So that means there's no GCF. We can jump right into factoring using the guess and check method. Again, our variable is x, so I'm going to write x and x here. 2 numbers that multiply to 10, but when I add them, give me a positive 11, and I'm thinking that is positive 10 and positive 1. And we are done. Oh, this one here, let's see what we have. Looks like I made a little typo here, but that does say 78. So let's see, I have an n, so I'm going to pull out an n. I have a 6, 78, and 216. So maybe 6 can come out. I'm going to say 78 divided by 6, that gives me 13. 216 divided by 6, that gives me 36. So yes, I can pull out a 6. So remaining, I have n squared plus 13n plus 36. And again, I need two numbers that multiply to 36 positive and add up to 13 negative. Excuse me, positive. This is both positive. So guess and check. Because our leading coefficient here is 1, it is missing, so therefore it's 1. I go guess and check. So here's n, and let's see what else we got. We have two numbers. I'm thinking 9 and 4 again, because 9 times 4 is 36, and 9 plus 4 is 13. So we're going to have a 9 that's positive and a 4 that's positive as well. Bring down your GCF, and you are done. Let's do two more examples. This one here, let's see if we have a GCF. So we have 5, 25, and 30. So I'm thinking 5 is our GCF. So if I pull out 5, I have r squared minus 5r minus 6 here. Again, leading coefficient of 1. So here I have r and r. Two numbers that multiply to a negative 6, add up to negative 5. That's going to be negative 6 and negative positive 1. And your GCF, and you are done with this one. Slowly coming to realize that you don't have any true examples of A is not 1. After we factor out our GCF, all of these examples give you A is 1 in the remaining bubble. So we might have to do a separate video for when A truly is not equal to 1 using the slip and divide method. Let's try this one. 3, 18, and 81. I think 3 goes into 81. It does. And then I have an N, and an N. So I'm going to pull out 3N. Once again, we're going to get something inside the parentheses with a leading coefficient of 1. So we have n squared minus 18 divided by 3. That's 6n. And we had 27. So let's see what we have here. Again, guess and check because our leading coefficient is 1 here. GCF is 3n. Bring that down. So two numbers that multiply to 27, but when I add them, give me 6. I'm thinking 9 times 3 is 27. We want one of them to be negative because both 27 is negative and 6 is negative. So I'm going to make 9 negative because it is larger, and I'm going to add 3 here since it is smaller, and we are done. So these were examples where you originally started out with A not being 1. However, after factoring out the GCF, it does end up giving us a leading coefficient with 1 for our trinomial. In the next video, we will do true examples of when our leading coefficient is not 1, and we will use our slip and divide method. Thank you so much for watching. Bye!